So what we're going to do is we're going to continue on with this lesson here. We're going to take a look at how we can use these probabilities that we found to predict outcomes. Now, when we talk about predicting outcomes, we're trying to figure out if we are going to do something so many times, what should we expect to happen? And we're going to use a probability to do that. So when a probability is known, the outcome of a series of events can be predicted. And I'll use the example of being late to class. Let's say that we know that someone is going to be late to class 1 out of every 4 days. Well, that means that if we look at a week, on a regular week, they would be late 1 or 2 times based on that, because there's 5 classes. Now that would be a normal class, not a COVID class time, but we can predict how things are going to go. To predict how often an event will take place, we multiply the number of total occurrences by the probability as a decimal or as a fraction. So we're going to put the probability into a decimal or a fraction. So that means if it's as a percent, we need to divide by 100. And then we're going to multiply by the total number of occurrences. Now, these predictions are not exact, as real life doesn't follow theoretical rules all the time. So the predictions that we're making are just based on theoretical probability, not necessarily on exact. Again, if we say that someone's late a quarter of the time, they could be late 5 days in a row and then be on time the next 15 days. Okay? That would be 1 quarter. But that would kind of skew with our close and small numbers. So, but that is kind of what we would, let's say, expect to happen. So how do we do this? Well, the formula that we're going to use is we're going to take the probability of our event, multiply by the number of total events, okay, or total occurrences. That's what we're going to do. That's how we're going to do this. So the probability of a coin landing heads up is 1/2. Okay, that we know, that's our theoretical probability. If the coin is flipped 20 times, how many of them will be heads? Well, we're going to take the probability, 1/2, and we're going to multiply it by 20. Now 1/2 times 20, 1 times 20 is 20, 2 times 1 is 2. We can simplify this to 10, and so 10 times, 10 times will be heads. At least based on our theoretical understanding of flipping a coin and knowing that the probability of it landing heads is 1/2. Okay, here we used 1/2 as a number. We can also use it as a decimal. 1 divided by 2 is 0.5, so we could have used 0.5 as well. All right, let's do number 2 here. Dale drives for a food delivery service and knows that 75% of the customers give a tip. One evening he makes 13 deliveries. How many of them gave him a tip? Well, what we're going to do is we're going to take our probability, right here, 75%, okay, and we're going to multiply it to the number of total occurrences that he had. So 75%, 75 divided by 100 is equal to 0.75. We need to use that as a decimal to do our question here. So 0.75 times 13 is equal to 0.75 divided by 13, sorry, not divide, times 13, is 9.75. Okay, 9.75. Now, he can't make 3/4 or 0.75 of a delivery, so we're going to have to say that 9 or 10 customers gave Dale a tip. Let's just make that look a little bit nicer there. There. So 9 or 10 of the customers gave Dale a tip. Now that's based on what we saw here. Okay, 9.75, we would normally round it up to 10 if we were giving just an exact answer. Okay, 10 customers gave Dale a tip, but we could say it's between 9 and 10 because who knows with all the probability that we have, which one is going to be the exact value. All right, last little part here is if we want to determine the opposite amount, okay, so let's say the negative amount, so to speak, we'll either have to find the opposite percentage and then solve, or we'll have to solve for the times it works and then subtract from the total occurrences. So here's our question. It says a team wins 37% of their games one season. How many losses did they have through 60 games? All right, this is the number of games this is the percentage that they won. Okay, we want to figure out how many losses did they have. Two different ways that we could do that. Firstly, we could take our percentage, write it as a decimal, and multiply it to 60. Now 0.37 times 60 is 22.2, so we're going to say 22 wins. Then we do 60 minus 22 is equal to 38 losses. So that tells us that they're going to have 38 losses through their 60 games. Okay? Because they had 22 wins. 60 minus 22 is 38. The other way that we could do it is we could do 100 minus 37. Okay, 100% minus 37% is equal to 63% of the time they lose. Okay, 63% of the time they lose. Then, should actually be using a different colored pen for this, apologies. 0.63 times 60. 0.63 times 60 is 38 losses. Okay, you'll notice it's 37.8, but we'll round up because we're going to try to keep them exact. So 0.63 times 60 is 38 losses. Now that's exactly what we said here. So there's two different ways. We can either find the number of positives and then subtract to find the negative, or we can subtract the percentage and find the probability of the negative and then solve for how many. So there's two different ways to do that. Now, that is all for this little lesson here. I want you to work on assignment ST.01, questions 9 through, and I want to say 14. I'm just going to quickly double check. We're looking at all? 14. 9 through 14. Now you should be done 1 through 8 already. And once you're finished, please hand in those, just as we always have. There will be a weekly progress check as well on stats and probability. And so it's going to deal with stats and probability.